All right, we're going to jump on a topic that we were very strong at earlier in the year, and then we just haven't seen it much recently, except on a grizzly or two. And I want to talk about solving a system of equations, specifically when one of the equations is linear and one of them is quadratic. So what we've got here is two equations. The first one on top is quadratic because of the squared term right here, and then the second one's linear all the way across because the biggest exponent you ever see is a 1. Now what I want to do is I want to jump on the linear. I always start with the linear, and what I do is I rewrite that so that y is by itself. What I'm going to do is we could, well, depending on how you want to say this, we could subtract the 4x over and then divide everything by -1, and there's a couple other methods, but basically here's what you're going to end up with. Y equals 4x minus 5. So basically what we're saying is y is equivalent to this expression, and anytime we see a y, we could substitute the quantity 4x minus 5 into his place. Now on the Grizzlies, when we've seen this particular topic, we've had the right idea of substituting, but we've just gotten a little sloppy and we've substituted that expression in for the wrong variable. So talk yourself through it. Keep telling yourself it's y that's equivalent to this expression, and therefore that quantity 4x minus 5 needs to get substituted in for y only. If we rewrote that top one, we could say 4x minus 5 equals x squared plus 2x minus 8. What I want you to do right now, really quick, as fast as you can, is we're going to hit pause, we're going to move all the variables over and solve this one, and then come up with your final solutions. Now don't forget, just when you get x, you're not quite done yet. You want to find the corresponding y values that go with those x's. Come on back, and we'll see if we got the same answer. So real quick, here's what I got when I added all the terms, or moved all the terms over and factored it and so forth. I got x equals 3. Now what I'm going to do is I'm going to substitute that 3 right here, and 4 times 3 is 12. 12 minus 5 is going to give me 7. So what that means is the ordered pair 3, 7 is one solution. I'm also going to take the -1 and plug it in up here into x, and 4 times -1 is -4 minus 5. That gave me y equals -9, and therefore my second solution is -1, -9. Whoops. That's a little hard to read. Fumble that a little bit. Anyway, so here's when I'm all said and done, and when someone picks up my particular test, here's how I'm going to list I'm going to put them in numerical order, and I've got my two ordered pairs expressed in solution set notation. There we have it. Alright, here's our second example, and what I'd like to do on both of these is just try to get y by itself on both of these. Particularly on the first one, all I'm going to do is I'm going to cross multiply, and I could say y is equivalent to x squared minus 9. And on the second one, I'm just going to add the 3 over and say y is really equal to x plus 3. So looking at the linear here, I'm saying y is equivalent to the quantity x plus 3, so I'm going to grab that quantity, or that expression, and substitute it into the first y, thus getting a new equation that looks like this. And if nothing else, I want you to walk away tonight feeling better about isolating the variables and substituting a quantity into the appropriate place in that other equation. From this point on, I'm going to move all the terms over to one side, and I got a minus x now, and I got a minus 12. Notice I'm not going to get sloppy. I'm going to continue to bring that 0 down with me, and I got x minus 4 times the quantity x plus 3. And now we're going to tee it up. Mathematically, it's called the zero product rule, and basically what we're saying, if x is equal to 4 or if x is equal to -3, then the product between these two quantities will be equal to 0. I want to plug the 4 back in up here and get y equals 7. I'll also take the -3, plug it into the same spot, and get y equals 0. However, there is a very sneaky bear trap on this particular problem. If you look at that first equation, and that's why I chose this problem, if you look at the denominator here, we're going to make a note right away that says x is not allowed to be positive or -3. And we're going to put that restriction on that function's domain. Now because of that restriction right here, we're going to sneak down here and reject this one. And we're going to say that the only solution to this problem is the ordered pair 4, 7. That's the one and only solution because of the restriction on this first function's domain.